Hey, what's up? I'm Aubree,
And I'm Ryan.
and this is our study on the feasibility of Energy Vault's new EV Power Tower. And we are not talking about the Pokemon.
I stumbled across this perfect real life example of the conservation of energy when I was reading an article on popular mechanics. This tower has a lot of power. It used recycled concrete that's been repurposed into 35,000 kilogram blocks that are then piled around a 6 arm crane. The crane uses power from an outside source like solar or wind to hoist the blocks and stack them in columns around the crane. The higher the blocks, the more potential energy they're storing. When it's time to use the battery, the crane drops the blocks back down to the ground in their original position and uses kinetic energy generated to power a generator and provides power to wherever it needs power. Energy Vault boasts an efficiency of 80 to 90% and a 30 to 40 year lifespan with very little degradation. Currently, only a 1/7 scale model has been built, but it's estimated that a full-size battery can provide about 35 megawatt hours of storage, and that's enough to last 8 hours of continued discharging at full capacity. As most of the numbers and figures on this battery were unavailable due to its stage in the beta process of development, we had to make some assumptions for our calculations, as seen here.
This is the tower and all of its stages, from full charged all the way down to no charge. The calculations we performed helped us form a more complete picture of this tower as a storage device. Using the weight of concrete and the estimated power storage, we calculated that each block would have a dimension of 2.4 meters in all directions. When stacked, you could fit 50 blocks to reach a maximum of 120 meters, which was the height provided on Energy Vault's website. Using these parameters and the power storage per column, we found that it would need 125 columns in the tower. From there, assuming the crane needed a tower interior diameter of 20 meters to operate, we found the total footprint of the battery and rounded up to 1 acre to match the figures on the company's website. We also found that at the base, the potential energy stored per block would be 837.8 kilojoules and would increase linearly in ideal conditions until the very top of the tower, where the potential energy would be 40,364.2 kilojoules. An area of concern for the tower is wind interference, as strong winds could buffet the blocks as they are being lifted or lowered, causing them to knock into the tower, put excess strain on the crane arms, or become out of place upon reaching the destination. For this, we assumed a maximum wind situation of 45 meters per second, or Category 2 hurricane wind speeds, which is obviously an extreme. We also assumed that the wind speed profile would be linearly increasing, with the maximum at the top of the tower and minimum at the ground. This would be unlikely in real-life scenarios, but for the sake of calculating the moment about one of the 6 crane arms, it worked. Using this profile, we calculated the force of the wind 2/3 of the way up the tower, and calculated the moment around a crane arm, assuming all wind was acting solely normal to a block. We found a maximum moment of 191.1 kilonewtons, which would have to be somehow sensed and controlled or counteracted by an actuator or dampening device within the crane. The windier the location, the less efficient the battery, as the power would have to be directed to the sway controlling device.
According to our estimates, the Energy Vault lives up to its claim. It seems to be an effective energy storage solution, utilizing simple conservation of energy principles and basic materials. Unrelated to dynamic principles of this device are the practical and environmental applications. The concrete is reportedly recycled from construction and demolition sites, reducing the carbon emissions related to virgin concrete production. It is more desirable than similar potential energy storage solutions that use water or hills by removing the need for specific geography or resource needs. Several companies around the globe have already partnered with Energy Vault, as the potential is not hard to see in this product. It is currently 50% less expensive than lithium batteries and has a longer lifetime and higher efficiencies, and requires no rare earth elements. Servicing the towers is designed to be very simple and minimal. As electric vehicles and equipment start to replace fossil fuel machines, our dependence on rare earth metals essential in batteries is growing at a rapid pace. Simple solutions using abundant materials are the true face of sustainability, and Energy Vault seems to be leading the first wave of green energy storage.
Thanks for listening in.